right, this is Unit 2, Lesson 1, Part 2. So this topic is function notation. So we introduced functions in the last lesson. So what we're going to do is teach you how to rewrite equations in function notation and then how to evaluate those functions. So this first box, just kind of introducing what function notation is. It says equations that represent functions. So remember at the end of the last lesson, we had seen mappings and tables and just sets of ordered pairs, but we also saw equations. And we graph them in Desmos. So when you see equations that are supposed to represent functions, a lot of times we write them like this. So this f of x, that's function notation, equals 2x plus 7. So this notation is just kind of reminding you that this expression is a function of x. So that's literally what this notation means. F of x means a function of x. It means that when you plug x in, you get a different number every time. And so this expression is changing as x changes. And that makes it a function of x. So in that scenario, x is the input. That's the value that you plug in. And then f of x is the output. That's the number that you get out after you plug in a certain value for x. So I'm going to show you one example up top of what it looks like to evaluate functions. So this notation, we use it if you want to find a value in the range, meaning a y value, that corresponds to a certain domain value, meaning an x value. So this says if f of x is equal to 2x plus 7, so same one from up here, find f of negative 3. So remember what this means is this guy right here is an x value. So that's an x value. And this notation is literally just saying take this x value of negative 3 and plug it into our function. So that looks like this. So we take 2, but then in place of this x, we're going to sub in a negative 3, and then plus 7. So it looks just like this expression right here, except the x that I had right here, I'm plugging in a negative 3. And then you just evaluate it. So 2 times negative 3 is negative 6, plus 7 gives us 1. So what that means is that when I plug in an x value of negative 3, I get a y value of 1. So we're going to practice a handful of these. First one I want to look at is number 1 right here. So up top we have two different functions. So this is the function f right here. This is the function g right here. So when you see different notation, like when we look at number 1, for example, this letter f tells us what function we're supposed to be using. So that's why we use two different letters, f for one of them and g for one of them. So this letter f tells us we're supposed to be using this function right here. And then the negative 9 tells us that negative 9 is what we want to plug in for x. So that'll look like this. We have negative 5, and then instead of the x, we're plugging in this negative 9, then minus 14, and then you just evaluate it. So negative 5 times 9 is 45, and minus 14 leaves you with 11. So the answer for all of these on this front page should just be numbers. So we get 11 there. So let's look down. So these ones are all the same thing. You're just taking different values and plugging them into one of these two functions. Let's look at the ones that look a little bit more complicated. So this one you have f of 1 and then minus f of negative 4. So we need to figure out what this is, figure out what this is, and then we'll subtract the two values. So f of 1, let's find that first. So we're plugging 1 in here. So negative 5 times 1 minus 14. So that is negative 5 minus 14, which is a negative 19. So we find that first. Then find f of negative 4. So same thing, just a different number to plug in. So this, negative 5 times negative 4, leaves me with 20, and then minus 14 would be 6. So we find each of these numbers right here. The final answer is supposed to be this one minus this one. So for my answer, I'm going to take the negative 19 that I got here, minus the 6 that I got here. So negative 19 minus 6 is a negative 25. And that would be your final answer. So you evaluate two different ones and then subtract what you get. Number 6 is also kind of an interesting looking one. We have 2 times g of 12. So order of operations would tell us we're supposed to focus on what we've got going on in these brackets first. So we are going to figure out what g of 12 is. So this time we're using g. So that's this other function up here. So we want to use our function g, plug into 12. So we've got two different spots where there's an x. So we have negative and then 12 squared plus, let me put that in parentheses, plus 9 times 12, and then minus 1. So we can evaluate that. So be careful here, when you have negative 12 squared, you would square the 12 first and then make it negative. So that actually is a negative 144. And then 9 times 12 plus 108, then minus 1. So you could plug that into a calculator. That's what I'm going to do. So we end up with a negative 37. Okay, so that's what you get when you plug the negative 12 in. So we get a negative 37. And then it tells us that we are supposed to be multiplying that by 2. All right, so then for our final answer, we remember that we have this 2 times the number that we found. So when we multiply that by 2, we end up with negative 74 for our final answer. So that's how that process works. All right, so now underneath, on the rest of this page, we have 2 new equations. We have p of x, so we have a function p, and then a function q of x. So these are all just more examples of the same type of thing. So we're gonna look at number 8. Number 8 is asking us to evaluate q of 5. So we use function q, which is this one right here. Notice we have absolute values on this one, so that's gonna be a little bit different. So if we wanna plug in the 5, we have absolute values of 3 times 5, so the 5 plugs in where there was an x, minus 5 to the third, and then that's inside the absolute values. So we evaluate what's inside first. So 3 times 5 is 15, minus 5 to the third is 5 times 5 times 5, and that's 125. So inside the absolute values still, 15 minus 125 is negative 110. And then last thing we need to do is apply the absolute values. So remember, absolute values makes it come out as a distance, makes it come out positive. So that would be 110. But make sure the number on the inside is totally simplified before you apply the absolute values. All right, so that's one example there of just plugging in a plain old number. On the next page, we have the ones that look a little bit more complicated, so I want to make sure we're focusing on those. So this one we have 7 minus q of 4.5. So I just want to get q back up on the screen. Okay, so we've got that function, just so I don't have to keep flipping back to the equation on the previous page. So we want to figure out what this is first. So q of 4.5, and then we're going to do 7 minus that number. So in the absolute values, we have 3 times 4.5, and then minus 4.5 to the third. So we can sub those in, because those are decimals. So we'll plug them into our calculator. So 3 times 4.5 is 13.5, minus, and then 4.5 to the third. You're multiplying that by itself 3 times. And that gives us a lovely 91.125. All right, so now do that subtraction. 13.5 minus 91.125. So the number that we get underneath is negative 77.625. And I'm just plugging that right into my calculator. So now we apply the absolute values. That would be a positive 77.625. So that's just this part of it first. Then look at the rest of the expression. I have 7 minus that number. So for my actual answer, I do 7 minus 77.625. So that gives me a negative 70.625. And that would be my final answer for number 11. All right, so let's look at one more of these. That's kind of the funny looking version before I change things up. So function p is on the previous page. I'm going to copy that down. It's this one right here. So 1/2 minus 4/3 x. Just so we don't have to keep flipping. So focus on what's inside the brackets first. We want to find p of -1. Once we know what that is, we can plug it back into that expression. So p of -1, we've got 1/2 minus 4/3 times -1. So 1/2, and then this is just a negative times a negative, so it's plus 4/3. We want to make sure we're able to add fractions together. That means getting a common denominator. So I could use a denominator of 6 here. So this would be like 3/6 plus 8/6, and when I add that together, it gives me 11/6. Okay, so 1/2 plus 4/3. When I get a common denominator, I get 11/6. Then I can sub that back into this expression right here. So I have 3 times 11 over 6, and then plus 5. Okay, so that 3 over 6, you can reduce that down. So this, like the 3 over 6 reduces down to 1 over 2. So now I'm taking 11 halves and adding it to 5. So 11 halves, to add it to 5, I'm gonna write 5 as 10 over 2. That way I have the same denominator, and I can add them together. So that gives me 21 over 2. Or if you prefer in decimal form, you could definitely do it that way. All right, so that's the main type that you guys are gonna be looking at, where you're just plugging in numbers. If we look down here, we've got this one where you have a different function, and they tell you what that function is equal to instead and ask you to solve for x. So we're gonna do that. So f of x equals 34. So this time we're taking f of x, which we have written right here, and we're gonna set it equal to 34 and solve that way. So this is just kind of solving an equation. So this one, we're gonna start by subtracting 19 from both sides of the equation. So when we subtract 34 minus 19, we get 15, and then divide both sides of that equation by 3. So 15 divided by 3 leaves us with 5. So that's kind of reversing the process. That's basically saying if I were to plug 5 in, I would get 34. So I'm working my way backwards. All right, number 15, let's look at a little story problem here. This says, Owen paid a landscaping company $108 for an initial lawn treatment, $74 per month. So we get this equation, 108 one time, and then 74 per month. So T is the number of months. So let's look at part B. This says, how long has Owen been receiving lawn service if he has paid a total of $2,994? So this represents what he has paid. So this is the amount that he has paid, which we know was $108 up front plus $74 per month. So just like we solved for this equation, we'll be able to solve for this one. So start by subtracting this 108 from both sides, which I'm just gonna plug into my calculator. So subtract 108, so we get 2886 is $74 per month. And then to figure out how many months it's been, we divide both sides by 74. And again, I'm just plugging that into my calculator. So when you divide by 74, we get 39 is equal to T. So that is 39 months, which would be 3 years and 3 months. All right, let's move on to our last section, our last type here. So we have 2 more functions. These are our last 2. We have f of x and g of x. And then these things right here are asking us to plug expressions now into these. So it's the exact same concept. So number 16, we want f of c plus 2. So instead of just plugging in a number, we're plugging in something for this x. It's just gonna be a c plus 2 instead of just a number. So we have -4, and then in place of the x, we're gonna put in parentheses a c plus 2, and then finish off the rest of it, plus 9. So the only difference is that this is a full expression instead of just a number. The rest of the simplifying still works the same way. So distribute the -4, like that, and then you still have plus 9, and then you just simplify it as much as you can. So combine like terms, and we get this. So for all of these, you should have an expression as your final answer. Let's also look at number 18 so we can see our function g. So this one is x squared minus 5. So it's saying we want to plug this in for x. So x squared, we plug this thing in and square it, and then minus 5. So when we square this thing, you want to make sure you're squaring both parts of it. So like -4 times -4 is 16. And then y to the third times y to the third would be y to the 6th. And then just minus 5, like nothing there, nothing's like terms. So it's just that expression. All right, last one here. We've got g of 2m plus 1 and then minus f of 3m minus 7. So I'm gonna find this part first. So g of 2m plus 1. So we're taking 2m plus 1 and plugging it in for x here. So 2m plus 1 squared, and then minus 5. So it's just this expression, I just plug this in for x. So now when I square this, that means I have to write it out twice and FOIL it. So squaring that expression means I'm writing it twice and FOILing it. So FOIL 2m times 2m is 4m squared. Outside gives me a 2m, inside also gives me a 2m, so that's a 4m. And then last, 1 times 1 is just 1, and then you have the minus 5 after. So combine like terms, just the constants at the end. 1 minus 5 would be a negative 4. So that's what I get when I plug this into G. Now let's see what I get when I plug this into F. So I'm going to find this part next. So remember, this is my function f. So I have negative 4 times this expression, 3m minus 7, and then plus 9. So this one's going to be a little bit easier because I don't have to FOIL anything. So just distribute the negative 4, which is negative 12m plus 28 plus 9. So that gives me negative 12m and then plus 37. So I've got my two separate expressions. Finally, this thing is asking me to subtract. So I take what I got from function g over here on the left, and I'm going to subtract what I got from function f over here on the right. Okay, so just combine like terms, 4m squared, that's the only m squared term. Then for the m's, I have 4m minus a negative, so plus 12m, that's 16m. And then I have negative 4 minus 37. So negative 4 minus 37 is a negative 41. So that's probably the craziest one we've got there. That is your final answer.